So in this case, we are going to consider our revision. That is a full paper for the March exams, so that you can be able to just understand how these questions can be given in terms of the March preparations. And as you are also preparing, remember this term, you have the assessments that you're going to work with. So some of the approach on how to answer the questions, it is very, very important because they are going to simply take them from these question papers. All right. So we are given, make sure that you follow the instructions, which is the information and instruction that you're given. That is according to our question paper, the most part here. If necessary, round off answers to 2 decimal places unless stated otherwise. But every instruction that you're given there is important. Very, very important. So go through your instructions. So I'm not going to waste our time. I'm going to quickly rush through the questions so that you can see how we're supposed to attempt these questions. On question number 1, you were given to solve for x 1.1. Okay. 1.11, we are given an equation that we are supposed to actually solve for x. And these are 2 brackets that we are given. And these 2 brackets are being equated to 0. Take note, the number that you're having there is a 0. So remember the 0 product. The product of A and B to be equal to 0, it is either one of these 2 must be equal to 0. It's either A must be equal to 0 or B must be equal to 0. So that's the condition, our A and our B from the brackets that we are given. So we can conclude that it is either 3x plus 4 must be equal to 0 or this bracket of x minus 2 must be equal to 0. So thus we can solve for x, all right? So taking the first part, x is going to be what? The 4 to the other side was going to be -4. Definitely going to divide because it was supposed to be like 3x. So you divide by what? By 3. So our x was going to be -4 over 3, or x is equal to the -2 to the other side is going to be what? A +2. That's 0 plus 2, which is 2. So these are the possible values of x, all right? For 2 marks, I think this is direct. Considering the other part on 1.12, again, it is to solve for x. Correct to 2 decimal places, as we are given this instruction, you're supposed to follow the instruction. So how can we solve this? That's a quadratic equation. 5x squared is equivalent to 11x minus 4. Remember your quadratic equation using the quadratic formula, but we must have the format of ax squared plus bx plus c is equal to 0. One side of the equation must be equal to 0. Are we having that? No. So we have to make this format, make sure we have got the format that we're having there. So what are we going to do? Just transpose these other terms to the other side of the equation. That is 5x squared. The 11 to the other side was going to be in negative. Remember, it's positive here. So it's going to be -11. Therefore, it is negative. So here it is going to be positive. So that's +4 is equal to 0. Once you are given the instruction that to 2 decimal places, guys, or maybe 3 decimal places, whatever instruction that you're given there in terms of the number of decimal places that you're going to use on your final answer, never waste your time trying to factorize this. This is direct for the quadratic formula or for the completing of the square method. So I'm going to use the quadratic formula. For those who are interested in using completing of the square method, you can use that. I talked about it as an introduction. All right, so from our formula, x is equal to minus b plus or minus the square root of b squared minus 4ac, everything over 2a. Remember, the division affects everything. So in our case, a being the coefficient of what? X squared. So our a in this case is equivalent to 5. Our b is the coefficient of x. So our b is equivalent to -11. All right. Then c is the constant. So C is equivalent to what? To 4. So let us substitute into this formula. X is equal to minus. The first thing, guys, is to substitute properly into the formula. Minus, what is our B? Negative 11. So that's minus 11. Okay? Plus or minus the square root of, you substitute B as it is, minus 11 squared. Substitute everything as it is. Minus 11 squared, minus 4 times A. Our A is 5, so you can just open a bracket. Our C is 4, just open a bracket also. All right, everything over what? 2A, that is 2 times what? 2 times 5. You substitute. That's it. Then, like I said, it is important for the examiner to know the stage after this. As you as to simplify the minus and the minus, these numbers under the square root. It is just important for the examiner to see this stage. So a minus and a minus, that's a plus. All right, so you're going to have plus or minus the square root of. You simplify these numbers that are under the square root. All right, so for the numbers under the square root, we are going to need our calculator. All right, so let us try to simplify this. That's minus 11 squared. So open a bracket, minus 11 squared, minus 4 times 5. So this is minus 4 times 5 times 4, just like that. These are the numbers that are under the square root. So you're going to obtain a positive 41. So that's 41, everything over 2 times 5, which is 10. So that's it. We are going to obtain the values of x by simplifying each, starting with a plus. That is going to have the fraction 11 plus the square root of 41, everything over 10. So that was going to give us this, and we changed to this as D. That's 1,74 to 2 decimal places, or you can fix our calculator, shift, go to the setup, then fix on number 6, then press 2 to 2 decimal places. All right, that's 1,74. So this is 1,74, or x is equal to, on this other side, taking the negative this time. All right, so taking the negative, just going to put a negative here. That was going to give us 0,46, which is a positive also. So that's 0,46. So that's it, guys. This is how we can use simply apply our quadratic formula in solving the quadratic The quadratic equations. So make sure that you go through the introductions of these. I talked about these separately. Quadratic formula, the completing of the square method. So it can help, guys, because you need this in your March exams. Question number 1 is going to be similar to this one. Very, very similar. If you work out, I'm going to work out different provinces. You will see it is just similar to each other. Very, very similar. All right. On 1.13, we are given to solve for x again, 4 marks, which is back to our sets. As we are working with the sets, we know that we have got equations which are under sets. All right. I'm just going to rewrite this so that we can have our question properly. That's the square root of 2x plus 7 is equal to 4 minus x. Remember, when solving these equations under sets, you make sure that the part that has got a set is on its own. The square root is on its own. This is exactly what we have. Once we have this, we are going to clear the square root by raising to the exponent of 2, by squaring both sides of the equation. It's an equation, you square both sides. To square on the left-hand side is simply to neutralize the square root, this one. Remember, we are doing this in order to remove the square root. So meaning to say we are going to remain with what is under the square root, which is 2x plus 7. So 2x plus 7 is equal to the square of this. How do you square that? It's either you're going to have 2 brackets of 4 minus x, another bracket 4 minus x. It's up to you. You expand these brackets. Or you can simply use your identities, as you know that a minus b squared is equivalent to a squared minus 2ab plus b squared. All right. Remember the first term, the last term concept. This is from our grade 10 mathematics. This must be clear. So that's our A and this is our B. So if we are to consider this, we were going to have A squared, which is 4 squared in part of A squared. So that's 4 squared, this one, which is what? 16. So we're going to have 16 minus 2ab, that's minus 2 times a, which is 4 times b, which is x. So take note, this is your a and this is your b. So what is the product of these two? That's minus 8. So we've got minus 8x. Then the last part is plus b squared. Our b is x, so that's x squared. So that's plus x squared, just like that. So you knowing these identities, they're identities under algebra, special products. Check those special products. I talked about it, about these ones. So make sure that you go through them for your revisions. All right. So as you can see, I've got a quadratic equation since the highest exponent in this equation is 2. So definitely we are going to need the format, just like the previous case. We need this format, ax squared plus bx plus c is equal to 0. So it's either we're going to take these terms to the left side or you're going to take these terms to the right side. It was up to you. So as we can see, it's easier to remain with the right side. So I'm going to take these terms to the right side, all right? Also maintaining the order ax squared. So it means I can start with x squared. So that's x squared. I'm supposed to follow what? X. So I'm having minus 8x. Take the 2x to the other side. So it is going to be what? Minus 2x. Remember, it was a positive, so it's going to be negative. I move on to the constant already. I'm having a 16 here, so it's going to be 16. I take the 7 to the other side. It's going to be what? Negative 7. So this stage is not even necessary to show it. As long as you can understand, guys, to subtract mentally by just, you can do that. All right? So that's 0 is equal to x squared minus 8 minus 2, that's minus 10. All right, 16 minus 7 was going to give us positive 9. As we can see, we have one side equal to 0. So we can solve our equation. And also, guys, if I write A is equal to B, and someone is writing B is equal to A, are these two different? No, they are not different. They're just the same. So these two are simply the same. I can equate the way that I want. Meaning to say I can start with this side because we are used to have our expressions on the left side. Not to say if it is on the right side, it's wrong. No, just that we are used to that. So it's going to be x squared minus 10x plus 9 is equal to 0. Then you solve the way that you understand. You have your quadratic expression on the left side, the way that you are used to, and it's up to you. It's up to you. How to solve then? Using factorization, or you can use your quadratic formula. It's up to you again. So I'm just going to take advantage of the factorization method here for the sake of revision also. Most of us, we do not want to see this factorization method. All right. There, the coefficient of x squared is 1. So take advantage of that, guys, because you're simply going to have x here, x here. The product, x times x, giving us x squared. Then you focus on the constant. This is our constant, 9. The products of these, or of any two numbers, that will give us these. But these products must add up to negative 10. Do we have two numbers? You multiply two numbers, you get positive 9. When you multiply the numbers, you must get positive 9. But when you add, you must get a negative 10. So as you can see, the 10 is just between 9 and 1. That is where we have the 10 there. But to have a negative 10, it means we must have negative 9, negative 1. Guys, let's multiply this. Negative 9 times negative 1, it's what? Positive 9. Let's add this. Minus 9 plus minus 1, what do we get? Minus 10. Exactly what we want. it must satisfy these two conditions. The product must give you this. The sum must give you this. Not to say it satisfies one condition. No, it must give us both conditions. The product must be this. The sum must be that. If one fails, guys, it's wrong. That is why we call this trial and error. Try another factors, because maybe you've got 9 and 1. Look, if you multiply 9 and 1, you get positive 9. It means on the product, it's correct. But let's go to the sum. If we add this, 9 plus 1 is what? Positive 10, not negative 10. It's positive, meaning you say it's totally wrong. But it satisfied one condition. The other one is wrong. So you do not take that condition. So be very careful there, right? Most of us, we just focus to say, okay, do I have two numbers that I add to get negative 10? You end up even taking -5 and -4. But if you multiply this, are you going to get this number? No. The question is, does it satisfy both conditions? All right, so in our case, we have got both conditions, guys, from -9 and what? -1. So that's -9, -1. Each of these brackets, as we had question number 1, remember question first part here, 2 brackets being equal to 0. Are you seeing it's a repetition? They are repeating the same thing, 2 brackets equal to 0. So what does it mean? One of these must be equal to 0. So x is equal to what? -9 to the other side was going to give us positive 9. Or our x is equal to what? -1 to the other side was going to be positive 1. These are equations under sets where there is a square root. So we must test the values of x to see if they are going to satisfy the conditions that we are given here on the square roots. Is these conditions satisfied originally that we had from these values of x? All right, remember, so we are going to test. So remember that we were given the square root of it was the square root of 2x plus 7 equal to 4 minus x equal to 4 minus x. Remember, this was our question. So we're going to test when x is equal to what? 9. When x is equivalent to 9, let's test. In place of x, we are going to substitute a 9. The square root of 2 times 9 plus a 7. Is it going to be equal to 4 minus 9? In place of x, you substitute what? 9. So it's 4 minus 9. So this was going to be 18 plus this one, which is 25. Square root of 25. And the square root of 25 is what? It's 5. You take positive values. There is no like plus or minus when dealing with the sets. You only work with what? Positive values. So we are getting 5. All right. Then here, if we subtract 4 minus 9, that's -5. These two are different. This is 5. This is -5. So it's not equal. So when x is equal to 9, it does not satisfy the condition that we are given. So therefore, this is totally wrong. We cannot have that as a solution. We move on when x this time is equivalent to what? To 1, all right? When x is equal to 1. Sorry, when x is equal to 1. So in place of x, I'm going to substitute 1. So that's the square root of 2 times 1 plus 7. Is it equal to 4 minus 1 in place of x? That's 2 plus 7, which is 9. So I've got the square root of 9, which is 3. Is 3 equal to 4 minus 1, which is 3? Yes, 3 is equal to 3. The left-hand side is equal to the right-hand side. This is exactly what we want. So this is the solution that we are going to have at the end. So therefore, our x in this case was going to be equivalent to what? Positive 1. So whenever you're working with the equations that are under sets, you have to test your solutions at the end. You must test these solutions to see which one is going to satisfy the original condition before we squared anything, the original condition that we had, right? So just like that, guys, these are your sets. All right, so any questions, guys? Let's communicate. That's why the comment section is there. for communication sake, so that we can see where additions need to be made. All right, on question 1.4, we're asked to solve for x. And what are we having? That's an inequality. Is less than 0. That's not an equation. So this is an inequality for 3 marks. All right, so let's see. Quadratic inequality. So there we are given, that was 1.14. The inequality, x squared minus x minus 56 is less than 0. Take note, this is just like f of x is less, it's simple, it's just this, that's the condition. It's simply like f of x is less than 0. So we know this from our working that we can use the different ways, actually. The graphical method, are you going to use the number line to see the values at the end? But there's steps that you need. Okay, like I said on the introductions, I talked about this. So make sure that you watch the videos about solving these quadratic inequalities. All right. So you need to have the critical values. That's the first thing. Calculate the critical values. This is a condition where you let your f of x to be equal to 0. That's when you calculate the critical values, where you let the function to be equal to 0. So in this case, this is our function, but our function can be factorized before we let it to be equal to 0. We can even factorize, all right, so that we can have our critical values. So let's factorize these guys. As we can see, the coefficient of x squared there is 1. So we're simply going to have x and x. I talked about this, x times x, to give us x squared. Then considering the constant, what is our constant? Negative 56. Two numbers, you multiply two numbers to get minus 56. But when you add the numbers, you must get minus 1, which is the coefficient of x. So the number that is here is negative 1. So do we have two numbers, guys? These two numbers, if we multiply these two numbers, we must get minus 56. Do we have 2? But when we add, you must get a 1. So looking into these guys, you can see that there's something between 8 and 7. In between 8 and 7. But as you can see, we need a negative. So one of these numbers must be negative. And for us to have a negative on the final answer, it means it is the bigger number, which is what? Negative. Or you can write, guys, 8 and minus 7. Remember, this is trial and error. You try, you multiply these, you add. If you add 8 plus minus 7, that's positive 1. If you add, not minus 1, as we need minus 1. But if you look into these two, if you multiply these two, you're going to get minus 56. If you add these two, you're going to get minus 1. Exactly what we want. Exactly what we want. So these are the numbers that we're going to have. Minus 8 and what? Minus 7. So that's minus 8, and plus 7. And plus 7. So like I said, for the critical values now, which is finding the values of x, this is where you let your f of x to be equal to 0, as if you are solving this as an equation, as if you're given two brackets, x minus 8 into x plus 7 is equal to 0. How are you going to solve? You're going to take this to the other side, this one to the other side. You treat it that way. That is how you treat it. But don't write this as an equation. No, don't write this as an equation. This is an inequality. But as you find the critical values, that's how you treat this. So meaning to say x is going to be what? Minus 8 to the other side will be equal to positive 8. Or x is equal to the 7 to the other side is going to be what? Negative 7. So these are our critical values, the ones that we are going to use to determine the exact solutions of the inequality. So the exact solutions for the inequalities now, it's going to differ with the method that you are used to. Are you going to use the graphical method? Are you going to use the number line? It's up to you. For the exact solutions, to have these exact solutions, we must use any of the given methods. So from the graphical method, all right, let's consider, just going to consider just two, graphical and the other one, graphical method. So as for the graphical method, as we can see, I was talking about this one representing our f of x, all right? as it represents f of x, we can see that the coefficient of x squared is 1. Remember, ax squared plus bx plus c, the function. If a is equal to 1 like this, it's a condition where a is greater than 0, where we are going to have our function as a what? As a smiley shape like that. So this is what we're going to have, something like this, a smiley shape like this. All right. As we can see, there are two solutions. So we're going to have our x-axis, which represents the conditions where f of x is equal to 0, where y is equal to 0. It's in the what? X-axis. One is negative, one is positive. So you can just take the negative to the left side, the positive to the what? Right side. So this is the condition of our function. But we are given that this f of x is less than 0. The whole function is less than 0. I said when the function is less than 0, it is below the x-axis. You measure or you determine this because of what? X-axis. It is the one that is going to tell you where exactly you need your solutions. So when they say less than 0, that is below this x-axis, below this. So your solutions will be in between here. All right? And I said any solution taken in between is going to be written in which format? Therefore, our x is going to be greater than -7. All right? But less than what? Less than 8. Remember, I talked about this. When this is A, when this is B, you're going to have x is greater than A, but less than B. So in this case, these are the numbers representing A and B. Just like that. So we can work it from the graphical method. We can work it from there. The same solutions that we are seeing here could have been determined using what? The number line. To find these exact solutions. So that's another way that you could have. If you understand graphical, continue that graphical. If you understand the number line, it's up to you. So you work with what? With the number line. So for the number line, as we understand, guys, our number line is simply shows the values that we are given. -7 being negative, we're going to have it to the left. 8 being positive to the right side as we compare from what? From 0. Going to the left, going to the what? To the right, just like that. But that 0 is not important. So a number line is a direct method, guys, because I told you that if you are given a number line, this is not going to change. It's going to be the same throughout. These solutions, which are to the left side of the number that will be here, they will be referred as they are less than that number. So they are less than what? -7. I'm just using less than because our function there is what? It's just less than here. If there is less than or equal to, you also put that equal to there. But in this case, we do not have that one. All right? In between -7 and -8, how do you write your solutions? X is going to be greater than the smaller number, which is greater than what? -7, but less than the bigger number, which is 8. These are the solutions in between -7 and what? 8. From 8 going this side, these solutions, they are what? Greater than 8, bigger than 8 going this side. So you must test each condition out of these 3 conditions that we have. For values that are less than what? Less than 7. Just pick any value of your choice and test it back into this original or into this where we've got the brackets there. Because we are told that f of x is what? Less than 0. Less than 0 means what? Means the number or anything that we talk about there is supposed to be negative. So if you substitute a number in these intervals, you must get a negative value. All right? Remember, we are told that. All right? F of x is less than 0. All right? Let's just take our f of x. Remember, our f of x, it was x squared minus x minus 56. All right? I'm going to use this one, guys. You use anything that you want. All right? So for values that are less than 7, I'm just going to take -8. Less than -7, I mean. I'm going to take -8. You can take any one, -9, whatever that you want. But when you substitute here, you must get what? A negative. Less than 0 means our answer is supposed to be what? Negative. All right, so let's substitute -7, guys, and see. I mean, -8. In place of x, -8 squared minus in place of x minus 8 minus 56. So just use your calculator, guys. This was going to be 16, which is what? Which is positive. This 16 here, as we can see, it's a positive value. So in this interval that we are talking about, we are getting positive values. It's totally wrong because we are supposed to get what? A negative answer. But this one is giving us a positive. Guys, try any value of your choice. Any. Minus 9, minus 10, minus 11. Any. As long it is less than minus 7. This side, you are going to get positive answers. That means that whole interval is what? Is wrong. All right. Let's move on to another interval. In between minus 7 to 8, what can we choose? We can choose any value. You can even choose a 0 there because 0 is there. You can choose anyone, minus 6, minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5, 6, 7, up to 7. From minus 6 up to 7, you can pick any value of your choice. Substitute it into that f of x. So in this case, choosing 0, that's a 0 here, a 0 here. So this was going to give us what? Minus 56. Minus 56, that's a negative value. Exactly what we need. Our f of x is what? Less than 0. It's negative. And as we can see, we are getting what? A negative value. So this one, it satisfies the condition of our inequality. It's correct. It's giving us a negative value. That's the condition. So we're going to try also the last region or the last interval that we are given, where we are talking about values that are greater than 8, bigger than 8. Any value of your choice, 9, 10, 11, 12, any of your choice. So I'm going to pick a 9, substitute a 9 here, that's 9 squared, minus, in place of x, I'm going to substitute a 9, minus 56. So this was going to give us 16, and that's a positive value. As we need what? Where we are going to have a negative, but here we are getting what? A positive. So it's totally wrong. Anything in this interval is wrong. Is it 10 that you pick? Is it 11? Don't waste your time picking all values. Anything that you pick there is going to be what? Is going to be wrong. So our correct answer, where we have a negative, where f of x is negative, where this function is less than 0, that is where we need, is what? Is this interval in between what? This. So therefore, we're going to have our x being what? Greater than minus 7, but less than 8. That's it. As you can see, that's the same answer as what we got in our previous question. So questions can be like this. Inequalities, revise inequalities now, because the time for getting into the inequalities, when it is now time that you're supposed to be working with them, it's going to be too much. And that is the time that you'll be having many activities, many assessments. So it is better that you do work out your topics now before the assessments. All right, then we are given on 1.2, it was to solve for x and y there simultaneously. Solve for x and y simultaneously. This is what we have. All right. So we want to see how we're going to have this for 6 marks. Okay, so let's see. That's 1.2. So the first one, you were given 3 to the exponent of y, which is equal to 81 to the exponent of x plus 1. And another equation, it was given as x squared minus 6x minus 20, which is equal to y, like this. All right, so in solving these two equations, guys, we can just say, let this be our equation 1, and this will be our equation 2. As we can see, equation 2, we are already given y as the subject. Y is equal to an expression for x in terms of x. So there can be an easier way, guys. Okay, let's figure out equation 1. Because in equation 1, we do not have that condition of y is equal to. It is there, but it is hidden with the exponents. That condition is hidden with the exponents. 3 to the exponent of this, They are trying to hide that condition. So we must look into this. All right. Let us try to simplify it in the simplest form of 3. That's 3 to the exponent of y is equal to 81 as a prime number in the base of 3. That is 3 to the exponent of what? 4. Right? So 3 to the exponent of 4, but being raised to the exponent of what? To the exponent of x plus 1. So you must have that in simplest form. So the condition, guys, you must have that in what? Simplest form. So the simplest form is the base of 3. So you write that in the base of 3. All right? That is in the base of 3. That is the condition. All right? So given this, we can simplify 3 to the exponent of y is equal to 3 to the exponent, distribute by the 4, as we do understand our exponents, guys. An exponent to an exponent is simply have to multiply this. This is what we have here. So simply distribute this bracket by what? By 4. That's 3 to the exponent of 4 times x, which is 4x, 4 times 1, which is 4, like this. So as we can see, the bases are the same here, 3 and 3. And we understand from our exponents that if the bases are the same, the exponents will be what? Will be equal. So therefore, y is equal to 4x plus what? 4x plus 4. This is what we are obtaining from the equation 1 in a simplified manner. Yes, if you want, you can call it equation 3, since we've got equation 1, equation 2, equation, you can say equation 3. It's up to you. But it's something that you simplified from your equation 1. This is what you have. A linear equation in that manner, y is equal to this. In that equation 2, we're also given y is equal to this. What is that we can see, guys, here? Because we can simply equate the part of x, because this is y here. This is also y. So there's no way, guys. It simply means this whole part here in terms of x and this one in terms of x will be equal. There's no way, guys. Those two must be equal automatically. From this condition, this part of x squared minus 6x minus 20 must be automatically equal to what? 4x plus 4. Since we wrote it in terms of y, this one also, like y is equal to, in terms of x. We made y the subject. Also, y is the subject here. So you can simply equate. And by equating these, we have an equation which is in terms of x. And being a quadratic equation, we talked about this, guys. Always quadratic, ax squared plus bx plus c must be equal to 0. So I'm going to take these terms to the other side. So it's going to be x squared minus 6x. Taking the 4 to this side is going to be what? Minus 4x. Minus 20. The 4 to this side is going to be what? Minus 4. That's equal to 0 there. So you're going to have x squared minus 6 minus 4. That's negative 10. X minus 20 minus 4, that's negative 24, being equal to 0. So definitely we are expecting two solutions. There is a quadratic. So we can even use our quadratic formula, factorization. All right, it's up to you. So using factorization method, since the coefficient of x squared is 1, I'm simply going to have x and x here. All right, since the coefficient of x squared is 1. So that if you multiply x and x, that's x squared. Always, guys, like we had previously, you consider what? The constant. It's not going to change. Our constant, negative 4. Products. But these products, if you add them, they must give you negative 10. Do we have such? From negative 24, do we have product? Two numbers. From negative 24. You multiply two numbers. But if you take those numbers, add them, they must give you negative 10. It's a trial and error. A 10 and 12, there's something between 12 and 2 there. So to get minus 24, it is either this is minus 12 or this is minus 2. For us to get a minus 24. But we need a condition when we add, we are going to have what? Negative 10. Is it from this one? All right? Minus 12 plus 2, that's minus 10. Exactly what we want. If we add these two, 12 plus minus 2, that's 10. Not minus 10. So this is what we want here. Minus 12 and minus 2. So you're going to have minus 12 and what? Plus 2. This is plus 2. Minus 12 and plus 2. All right, just like that. So equating the brackets to 0 because this is the 0 product, guys. Minus 12 to the other side was going to be what? A positive. The 2 to the other side will be negative. So these are the conditions that you're going to have. X is going to be positive 12 or X is going to be a negative what? A negative 2. So that is, we have X values, but this is a simultaneous where as we are solving for X, we are also solving for Y at the same time. So using equation 3 where we made Y the subject, which is a linear, or even this one, you can substitute this one, which is a quadratic, but working with the quadratic, guys, where there's a linear, you can choose because there is a choice. So you can substitute in that quadratic or you can substitute into the what? The linear. So as for me, guys, I was going to take the easier one. Just going to work with the linear. Y is equal to 4x plus what? 4x plus 4. So when x is what? 12. What am I going to have? When x is equal to 12. So in place of x, that's y is equal to 4 times 12. Then we're going to add what? We're going to add a 4. So that's it. 48 plus 4, which is what? 52. Okay, so that's it. The value of y when x is what? When x is 4. In the same manner, we are going to have it when x is what? Minus 2. When x is equal to minus 2. So just substitute in place of x to have the value of y. Y is equal to 4 times x, which is minus 2 plus a 4. So what is it that you're going to have? Minus 8 plus 4, that's minus 4. So that's it. When x is minus 2, this is the value of y. When x is 12, this is the value of y that you're going to have corresponding to that. Simultaneously at the same time, you've managed to solve your equations. So it is a condition which differs. Sometimes you are given a condition where you are not having y as the subject, where you are forced to substitute the y that you get, you substitute in place. But here, when they're like this, it is up to you. When you say I'm substituting y in terms of y here, when you are saying I'm substituting this y where there is y, what does it mean, guys? It is simply equating these two because y is equal to what? Y. It's the same. All right. So from there, you solve way that you are used to. Guys, try to do as many questions. You see that these questions, they do repeat. It's just a repetition from one question paper to another. Like they do not have questions to ask you. Okay, it's just like that. On question number 2, simplify fully without using a calculator. This, all right? So there, even if you use a calculator, guys, how can you simplify that? Anyways, that's it, 2.1. So let's see our term expression that we are given there. That's 1 over, it was the cube root, all right? It was the cube root of p squared. So this is the cube root of p squared, everything being raised to the exponent of -3. So everything was being raised to the exponent of -3. All right, so exponents, it's all about the laws there. The laws. Let's start with this one. X raised to the exponent of m over n, we know that it represents the nth root of x to the exponent of m. So are we seeing that is happening here? So this is our n, this is our m. X to the exponent of m over n. So it simply means this was going to be 1 over p to the exponent of what? 2 over 3. Take note. The denominator is the number that is inside of the root. The numerator is our exponent. The numerator is our exponent. So that's 2 over what? 2 over 3. We have removed this by a law. There's a law. Everything raised to the exponent of what? Of -3. Is there a law that can be used to remove a negative exponent? Is there? Once you see a negative, if you are given a negative, let's say you are given m over n like this, raised to the exponent of -1, just a negative, this one, you interchange what is inside, so it will be n over m. The moment you interchange, the exponent becomes positive. You can interchange that. So once you want to remove a negative, interchange the fraction, the one that is inside, you interchange that. So by interchanging, it means it was going to be p to the exponent of 2 over 3 like this, over 1, raised to the exponent of what this time? Raised to the exponent of 3. It's now a positive 3. There's no negative there. But we have interchanged the denominator to the numerator. The numerator to the what? To the denominator. Guys, as we know our numbers, 2 over 1 is equal to 2. All right? If it is a over 1, it is equal to a. So dividing by 1, does it affect our calculations? No. This one, it simply means we have got p to the exponent of 2 over 3 raised to the exponent of 3. This over 1 is nothing. It's useless. All right. Let's go to our exponents. Laws again. An exponent to another exponent. What does it mean? When a is raised to the exponent of m and being raised to the exponent of n, we can multiply these two exponents, m times n. So these can be multiplied 2 over 3 times a 3. So that was going to give us what? P squared, all right? That's p to the exponent of 2 over 3 times a 3, which is simply what? P squared. 2 over 3 is going to mean this 3 and 3 are going to cancel. So that's p squared at the end. This is what you're going to have in the simplest form. In the simplest form from what we had here. So it's a play around, guys. Your laws, try to play around the information that you are given. It's very, very important that you do play around the information, apply that information that you're given. On question number 2, again, still on question number 2, but this is 2.2. All right, this was something else, guys, here. All right, they are saying, I'm just going to try to see if I'm going to use this space so that we see the question and where it is going. Maybe I'm going to win here. So if you are to consider 2.2, we are given that y is equal to the 6th root of 100,000. Without using a calculator, determine the value of this in terms of y. Our answer is supposed to carry y. Okay, let's just try to figure out this value before you talk about in terms of y. What's the answer here? Let's just try bring our calculator. Let's just try bring our calculator and see. All right, remember my calculator is fixed to two decimal places, but do not worry, we're just gonna use that. Is it 2 or 3? We see. So is the cube root of 16, the cube root, that's shift to go to the square root. So that's the cube root of 16. We just want to see, we are asked not to use a calculator, but we want to see the answer so that even you'll be sure about your answer at the end. All right, the cube root of what? 625 times the square root of 10 times the square root of 10 like this. It was going to give us 68,13, all right? That's 68,13. So we just want to see whatever that we are going to simplify thereafter. If we are to prove it, it must give us that same answer, but we said in terms of what? In terms of y, okay? So let's figure out. Looking into this value, because it is the one that must be in terms of y. This one is already in terms of y. So let's work from this value. They are saying the cube root of 16 times the cube root of 625 times the square root of 10. From our laws of sets, we are allowed to multiply if the numbers here are the same. A square root of 10 times the square root of 5. If it is square root to square root, you are allowed to multiply the numbers under the square root, 10 times 5. The same, if it is a cube root, if this is a cube root, if this is cube root, this is also supposed to be what? Cube root. So there is a cube root there, so we're allowed to multiply this. So it's going to be the cube root of what? 16 times 625. So yes, they say do not use a calculator, but guys, to multiply these numbers, do not crack your head trying to multiply these numbers. Use your calculator to multiply this, all right? 16 times 625 is going to be 10,000. So it means we have got the cube root of 10,000 here, which is multiplied to the square root of 10. All right. We are so far away from this, all right? From the look of things, we are given there. Let's try to figure out here. Y is equal to, let's take that Y and try to figure out. You understand me very soon. Remember, from what we are given that Y is equal to the sixth root of 100,000. It was 100,000. But if we check here, there is a 3, there's a 6. So it means if we continue this way, it's going to be complicated for us. So let's try to write maybe in the base, same base. And which base can it be? It can be the base of 10. So let's start with this side here. All right. Just hope, guys, this one. No problem. Let me just try to the sixth root. There's a 6 there. So let's start with this side. This is 100,000. Let's have it at least in the base of 10, because 10 is the easier number between these numbers. So remember our laws of exponents. This can be written as 10 to the exponent of what? 5. There are many zeros, guys. There are 1, 2, 3, 4, 5. So it's 10 to the exponent of 5. But remember the sixth root, like I said, guys, it means a fraction. So it's going to be 1 over 6. All right? So that is 10 to the exponent of 5 over 6. Guys, are we together here? Are we together here? Are we together here? The sixth root of 10 to the exponent of 5. 5 is our numerator. The number that is inside of the root becomes our denominator. I explained that before. So this is y written in terms of 10, like 10 to the exponent of what? 5 over 6. Okay? So let's try to have a 10 here and figure out. So here, guys, this type of a question, you cannot say, I know this question, I'm going to answer this. You figure out. All right? So you can see we are still very far. Let's figure out here. Can we have the base of 10 here? This is 1, 2, 3, 4. So that's 10 to the exponent of 4 being raised to the exponent of what? A third. The cube root means what? A third. Times 10, the square root of 10 means 10 to the exponent of what? A half. All right, that's 1 over 2. If we multiply here exponent to exponent, guys, 4 times 1 over 3. That's 4 over 3. This one, 4 times 1 over 3. So it's going to be 10 to the exponent of 4 over 3 times 10 to the exponent of 1 over 2. So there's something that is happening here. The bases are the same. Remember, when you are multiplying the bases that are the same, you can add the exponents. So it's 10 to the exponent of what? 4 over 3 plus 1 over 2. This was going to give us 10 to the exponent of 11 over 6. So it was going to be 11 over a 6. All right, we are almost there. We are very, very almost there. There we are having here where y is. It is given that y is equal to 10 to the exponent of what? 5 over 6. But here we have got 10 to the exponent of 11 over 6. Are we seeing something familiar here, guys? What is it that is familiar? Remember, as we want to rewrite this this part here, this is the one that we want to rewrite. Remove this 10 to the exponent of whatever that is there and put something which is y. I don't know it is going to be y to the exponent of what, or it's going to be y times what. But we don't want to see numbers. We want to see it in terms of y. Y is supposed to be there on our answer in terms of y. So where y is, it was the cube, it was the sixth root of this, which is complicated because there we do not have a sixth root. So we had to change to the exponents, change also this one to the exponent, but still they are not the same. Okay, there's something that can be the same here, which is the denominator, the 1 over 6. The 1 over 6, this one, the 1 over 6 like this, guys. If we take that, I want you to see this one where we took it from, guys. Remember a fraction. Okay, guys, 2 to the exponent of 3 over 4. It simply means we have got 2 to the exponent of 3 to the exponent of what? 1 over 4. That is what it means here. If we multiply this, it's going to give you 3 over 4. If you multiply these two. So in the same manner, you can even rewrite this as 2 to the exponent. You can even start with 1 over 4 like this. Raised to the exponent of 3. You take the 3 outside. Still, guys, you get the same answer. If you multiply 1 over 4 times 3, you get the same answer. So as we can see here, that something which is familiar on our answer, it is the 6. This one in the denominator, the 1 over 6. So let's write it in terms of 1 over 6. So this one is going to be y is equal to 10 to the exponent of 1 over 6 raised to the exponent of what? To the exponent of 5. At least you can see the 1 over 6. Here, we can also have that same 1 over 6 here because we can have this one as what? Because we want the same thing, 1 over 6. So this side is going to be 10 to the exponent of 1 over 6, but raised to the exponent of what? Raised to the exponent of 11. So as we can see, guys, 10 to the exponent of 1 over 6, 10 to the exponent of 1 over 6. So let's have this one in terms of y, because there y is, we have it. We have y there. So let's have it in terms of y. How do we remove this 5 and have it this side? Remember, when you are given exponents, guys, you're going to multiply by the inverse. 1 over 5 to the exponent of 1 over 5. So this and this one was going to cancel. So meaning to say, wherever we see 10 to the exponent of 1 over 6, we see y to the exponent of 1 over 5. That is what it means from this interpretation that we had here. From this part that we had, we simply had to find something common. But this one, guys, it's something that you have to figure out from the question. Now that you see it, to say, okay, 10 to the exponent of 1 over 6, this one, it is the same as this. This is the one that we need. So let's remove it. This one. Let's remove it. Because it is the same thing here. So we are going to remove it. But how do we don't just remove. You have to substitute with what is equivalent. So wherever we see this 10 to the exponent of 1 over 6, we see what? We see y to the exponent of 1 over 5. That is what we see. But on this side, it is not only that, because they are saying it is that to the exponent of what? 11. So it will be raised to the exponent of 11. Remember, I talked about this, guys. Exponent to exponent, you can multiply. So that's y to the exponent of what? 1 over 5 times 11. That's 11 over 5. Just like that. So you can write it like this. You can write it as the 5th root of y to the exponent of 11. It is up to you. It was just a hidden, not to say this is the only way. Guys, there are so many ways of answering this type of a question, but of those ways, we need, like, if you understand these basic laws, guys, some of these, we don't need to go through it. You can even see it by sight. You go, okay, this is where it's going to be like. But just for the sake of revision. So this is it, guys. We had to change this rewrite in another way. Not to say we have changed our question. No, we just wrote in the same manner, but in something that we understand. Then substitute that into this part. So we have written this in terms of y. So if we say this part here, if we say this part, because it must make sense. It must make sense to say the whole of this part that we are seeing. Remember, that is our question. Now it is written as what? Y to the exponent of what? 11 over 5. So let's test and see. Remember, we simplified it before here. I said if you simplify this, you are supposed to get what? 68,13. So let's prove it. Are we going to have the same answer if we say it is what? Y to the exponent of 11 over 5, because it simply means this is our y, this one. Remember, y is equal to this as a numerical value. We want to test if we are going to have the same answer. So y is equal to what? We substitute the sixth root. All right. So it's the sixth root of 100,000 like this. Raised to the exponent of what? 11 over 5. If we simplify this, we must get the same answer as it was before. That is to show that truly it is in terms of y and it is correct. All right. So let's substitute. This is it here. On our calculator, just open bracket. That's the sixth root. So we're going to have shift. You press this where there's x to the exponent. All right. So the sixth root, you press a 6 there. The sixth root of what? 100,000. So it's gonna be 100,000. All right. Close the bracket. Raised to the exponent of what? 11 over 5. So that's 11 over a 5 like this. So that is it. 68,13. As you can see, we are obtaining the same answer. 68. Guys, did I share the part that I wanted you to see? All right, here I'm busy explaining to myself. I'm supposed to have done this here. I wanted you to see this one here. The sixth root, which is this y here, the sixth root of this, then everything raised to the exponent of what? 11 over 5 like this. So this was going to give you 68,13. Exactly what we are having as we simplified it before. Remember, we simplified it before as it was originally. And it is still giving us the same thing if we have it in terms of what? In terms of y. So that means this is correct. All right. So this is just a matter of testing. We are just testing now. But to answer these questions, guys, so many ways. Yeah, there are so many ways we're going to see because of time, so that we try to figure out other explanations that you can maybe use, understand. Difference is very good for your calculations. On another part, you were given to determine the value or values of k for which this equation, all right, where k is not equal to 0, has real roots. This question, they actually do repeat. I've seen this in another provisional exam, which is not for Limpopo. I'm going to check which one was it. You see, they do repeat it. They just took this one as it is. I think it's supposed to be KZN, but they just repeated this one as it is. Anyways, let's see. They want a condition where this whole equation is going to have what? Has real roots. All right. So let's consider that it has real roots. We are given our equation 1 over k is equal to x squared minus x plus 1 like this. Remember, it's a condition where k cannot be equal to 0, but we need a condition that it has what? Real roots. Yes, real roots. Remember, when we are referring to the real values, that is, we are talking about values that can be on the number line, that can be simplified. The numbers that we can simplify. All terms that can be simplified that we have on our as long as it is part of your number line. All right. So if truly the roots are real, then it means our delta, which is the discriminant, must be greater than or equal to 0. But we know that this delta, which is b squared minus 4ac, it is a condition which is taken from a normal quadratic equation when it is written in the form of ax squared plus bx plus c, where we can properly see this so that we can have our b, our a, and c. But are we seeing that? No. And there's this fraction 2, we do not even have equal to 0. So it was either I was just going to take the k here and put it here as k, that way. And have b squared minus 4ac. Guys, how to solve these equations differs with your understanding. We can clear the fractions because this one is same as we've got it over 1. So you can clear the fractions, cross multiply, the k multiplies this side, the 1 multiplies this side. It's up to you. All right, so let's multiply 1 times 1. That's 1. There k is going to multiply everything. So it's k times x squared, which is going to be kx squared. K times minus x, that's minus kx. It multiplies everything. K times 1, that's plus k. So it's going to be plus k. All right. Then these two multiplies cross like that. 1 times 1, which is 1. So looking into our quadratic equation, we need one side to be equal to 0. So we're going to take the 1 to the other side. So it's going to be negative. So that's, we're going to have k x squared minus kx. All right. Taking the 1, we said it's going to be negative. So it was going to be plus k minus 1, which is equal to 0. With this equation that we have just formed, it is exactly our quadratic equation, one that we have the format. So what is going to represent a, the coefficient of what? X squared. What is going to represent b, the coefficient of what? The coefficient of x. What is going to represent c is the constant. In this case, our constant is the whole of this part, k minus 1. So that's it. So it's either you're going to calculate that delta on its own, or you just have to substitute because we have it, guys, that b squared minus 4ac must be what? Must be greater than or equal to 0 from this condition. So what is our b? All right, we say this is our a, this is our b, this is our c. So you're going to have b squared, that's minus k squared. So it means minus k squared. Minus 4 times a. What is our a? Our a is k. And what is our c? The constant where we do not have x. That's the constant where we do not have x. So it's k minus 1. That must be equal to 0. You have formed an equation from this statement. An inequality, I mean, from this statement we are having here, get rid here, greater than or equal to 0. We are not having an equation here. The equation was here. Now we have got what? An inequality. So we have formed an inequality there that we need to solve. And solving this inequality, let us expand. This is going to be minus k squared. That will be positive k squared. Remember, a negative raised to the exponent of 2. It's going to be positive. And this is minus k expanding the other bracket, this one. It's minus k, this one. It's a single term, this one. So it's going to distribute every term in this bracket. All right? So take note there. So that's minus 4k times k, which is minus 4k squared. Minus 4k times this minus 1, that's positive what? Positive 4k. Greater than or equal to 0. All right? That's it, guys. Now it's about inequalities. Forget about equations, guys. From this part here, we are now dealing with inequalities. How do we solve this? All right, let's just consider the like terms. 1 minus 4, that's minus 3. So we are going to have minus 3 k squared plus 4k is greater than or equal to 0. Guys, you have been given inequalities before of this nature where you are given to solve minus 3x squared plus 4x is greater than or equal to 0. You have been given this. How are you going to solve? It is in your hands whether you want to change this one to a positive. Guys, there's no need. You can do that, but there's no need because the negative tells us about the function. Remember, from our ax squared plus bx plus c, if a is less than 0, we are simply going to have what? Something of that nature. That is the condition. So in this case, guys, that is what is affecting our values. Otherwise, everything is just same. If you choose to have it as a positive, it means you have to divide by negative. The moment you divide this side by negative, the inequality sign reverses. You must be careful there. So as for me, I'm just going to maintain this one as it is. I'm not going to change anything because I can simply have the critical values by factorizing k, which is common. So it's going to be minus 3k. Remember, minus 3k squared divided by k. So it's going to be minus 3k. 4k and k is going to be positive 4, which is greater than or equal to 0. So therefore, our critical values as we let these to be equal to 0. So k will be equal to what? K will be equal to 0. Or from this bracket, we're going to have something like this. Minus 3k plus 4 like this is equal to 0. You saw 4k. So minus 3k is equal to minus 4. This one to the other side will be what? A negative. So let's divide. By negative 3, both sides, that's k was going to be a positive, which is 4 over 3. All right. So these are the critical values, the roots of the equation, not an inequality. No, this is when you are solving just as an equation. But for an inequality now, this one that we had simplified, it's going to be easier for you to examine or to see your solutions from this side, from this one, or you can use this one, which is what? Factorized. It's up to you. So yes, for me, I'm going to work with this one, all right? What does it mean? I can use the graphical method. It's up to you. Use any method, guys, of your choice to have the exact solutions. So using the graphical method, we can see that we've got a negative there. The coefficient of what? Of k squared is a negative. So meaning to say, a, when it is less than 0, that's a negative. We are going to have what? A Z shape like this, a Z face. That's what we're going to have. So thus, we are going to have this one as our 0 here and 4 over 3 on the right side. Okay, something like this. For if it was a positive, gonna have what? Smiley shape like that. But in this case, it's negative. So it's gonna be this way, guys. And I say that where this function is greater than 0, that is where it is above this axis. So where it is above, it is going to be here, where it is enclosed in between 0 and what? In between 0 and what? 0 and 4 over 3. How do you take a solution in between these two? X is going to be greater than 0, but less than what? But less than 4 over 3. Then consider the sign to say it was, take note, greater than or equal to, greater than or equal to. So what does it mean? On our final answer also, it must have that equal to there. It must be there. Your solution must carry the sign like the way it was. Not to say to maintain the greater to be like to be greater than, but the equal, if it is there. If it was just a greater than here, there is no equal to this one. It means on our solutions, we were not going to put the equal to this one. We're going to remove it. That's the only effect. But there's an equal to, so our solutions must also have that equal to. As long it is part of the solution. All right. As long it is what? Part of the solution, we're going to have that as equal to. So that is it, guys. As we can see, they do test you. You must be equipped. Very, very equipped in tests. Know all the basics. All the basics, you must know them. All right. So actually, if you know the basics, there's no need for you to actually go through all this. This is just for revision, guys, so that we understand, all of us. All right. So that is for the graphical method. For those who are to use the number line, I talked about this, guys. You can use the number line. Preferably your solutions that you're going to use. You test those solutions. We've got 0 here. We've got 4 over 3. 4 over 3 is 1,33, something like that. I said these solutions, this side of 0, they are less than 0. But because there's an equal to, so you're going to put an equal to. These solutions in between 0 and 4 over 3, these are solutions which are greater than or equal to 0, less than or equal to 4 over 3. Then these other values, they are greater than or equal to 4 over 3. So 4 over 3, like I said, this one is just like 1,3333. So when testing, you can use 1 to test. All right. So in fact, this is no longer x, but this is what k, like what we're given. This is k. Remember, this is for k. So you test. When k is less than 0, you can test any value. When k is equal to -1, you put it back into this function here and see if you're going to get what? A positive value. You must get a positive value. So you're going to see, guys, there you're going to have a negative, which is wrong. If you substitute a 1, you're going to get exactly a positive value, which is exactly what we want. This one was going to give us a negative. So the solution was going to be this one. So I want you to try with the method that you are used to, but I explained both methods, graphical, the number line separately. So find time to work out each method separately so that you choose which one is best in your calculations. On question number 3, which is the part of our trigonometry, we were given, do not use a calculator when answering question number 3. Okay, that's good. 3.1, given the tan of alpha is -9 over 40. In this interval, greater than 180 but less than 360. Definitely we'll need a sketch there. Use a sketch to determine the value of sine alpha plus cos alpha. So which quadrant is it, guys? Greater than 180, we are simply having, remember, this is 0 degrees as we count in the anti-clockwise direction. So it will be 0, 90, 180, 270, 360, remember. So between 180 to 360, this is where we have our answer. Our answer can be in the third or in the fourth quadrant. But which one is the exact solution? We are given there on our question 3.1 that the tan of alpha is -9 over 40. Negative. Where do we have tan being negative? We understand from the cast concept, all right, that tan is supposed to be negative in the fourth quadrant and in the second quadrant. Tan is positive in these two. The first and the quadrant for tan, all, and this one for t. Here it's cos and, but we cannot talk about these quadrants because they are already excluded on our answer here. It excludes because they are saying our alpha must be greater than 180. So it means these two, they are totally out here. Greater than 180, we're talking about these two intervals, these two quadrants. So in these two quadrants, which one are we going to take? This is the one where tan is negative. So it's going to be in the fourth quadrant. Analyze that part first. All right. So this is found in the fourth quadrant. If it is found in the fourth quadrant, therefore we're done. Because we know in the fourth quadrant, our triangle is gonna be like this, all right? So we're just gonna have our right angle triangle. Remember, these are the x values, these are the y values, and according to our tan from the SOHCAHTOA concept, remember SOHCAHTOA, all right? That's our tan is opposite over adjacent, opposite over adjacent. So according to this, if this is our alpha here, let's say this is where we have our angle alpha, what would be the opposite? The one that faces alpha is our opposite. So meaning to say our opposite is -9. Adjacent, this is our adjacent, which is what? Which is 40 according to alpha. This is our adjacent. This is the opposite. So what we need is to determine the hypotenuse in this case. We need the hypotenuse so that we can answer this question. Sine what? Because the moment we need sine, sine is what? Opposite over hypotenuse. Opposite over, we need the hypotenuse. All right? We need that hypotenuse. All right, so let us calculate that hypotenuse. Remember, from our Pythagoras theorem, the radius of the circle that was going to be drawn, which is r squared, is equal to what? X squared plus y squared, which is this is simply the hypotenuse, guys. All right, so let's substitute the hypotenuse, which is r squared. Right, r squared is equal to x squared. For the x values, we've got 40 plus the y values, that is -9. So that's -9 squared. Try to simplify this. 40 squared, that's 1,600 if you multiply. There you can use a calculator. Yes, they say do not use a calculator, but these ones you can simplify from your calculator. Do not worry about this. Add these two, you're going to have 1,681. To find our hypotenuse, which is r, we're going to introduce the square root. So r is equal to, that's 41. Remember, the hypotenuse cannot be negative. It's just positive values. So that is 41. That is our hypotenuse, guys. All right. You had to use your Pythagoras theorem. After that, you can simplify the question because we've got everything. The triangle is complete. So what is the ratio of what we are given? What is the ratio of sine alpha plus the cos of alpha? So sine alpha, as we have this one from our SOHCAHTOA, guys, sine opposite over hypotenuse. So we are going to have opposite over the hypotenuse. That is sine. Opposite over hypotenuse. So according to this, our opposite is what? -9 over the hypotenuse, which is what? 41 plus our cos. What is the cos of alpha? The cos of alpha is what? Adjacent over the hypotenuse. So according to our diagram, what is the adjacent? 40 over the hypotenuse, which is 41. So that's 40 over 41, as we do understand that if the denominators are the same, calculations can easily be done by adding the numerators. -9 plus 40, everything over what? Everything over 41. So it's simply like 40 minus what? 40 minus 9. That is what it simply means. 40 minus 9, which is what? Which is 31. So that's 31 over 40. So that's the whole sine alpha plus cos alpha. So we are going to definitely need a completed triangle. Pythagoras theorem has to play a role. It has to play a role. So, guys, as you can see, these are typical questions similar to these that you're going to have in your finals. So if there's a topic that you see having a challenge as you are, or as you be towards finals, it shows that it's going to be the same also in the exam. But for now, guys, we are not yet towards exam, depending with the time that you're watching this video. All right. Anyways, 3.2. Let us see 3.2. We are given if cos 32 is equal to k. Determine the values of the following in terms of k. Our answer must carry k. Cos 32, there we just need a diagram which shows us the right angle triangle, because as we do understand, it's a ratio, and a ratio is being taken from what? A right angled triangle. So let's say this is the angle of 32 degrees. According to this, cos 32 degrees is equal to k, is same as k over 1. Remember, we saw, guys, from our soccer tour, cos adjacent over hypotenuse. So we have the adjacent and the hypotenuse here. What is our adjacent? It's k. According to 30, the adjacent, we have got the angle and the 90 degrees. They are adjacent to each other here. So this is our adjacent, which is k, the hypotenuse, which is 1. So definitely calculate the third side. Guys, as we have our hypotenuse squared equal to side squared plus side squared, guys, what is our hypotenuse? That is 1. So 1 squared is equal to the shorter sides. So we are given k, which is k squared, plus the other side, we're going to call it b squared. 1 squared is 1. Take the k there, it's going to be minus. So it's minus k squared, which is equal to b squared. B is the side that we need to calculate the unknown. So we can just introduce the square root. So meaning to say b will be the square root of this. So this side here, guys, was going to be the square root of 1 minus k squared. So there I'm not going to explain much, guys. This is our Pythagoras theorem. We just answer the way that you understand. Some even by sight. By just looking into this, we can tell, say, this is 1, this is k, this is going to be the square root of this. So I end up even confusing others. But guys, this is direct. Anyways, let's answer the way that you understand. Then the question was, calculate this in terms of k, which is cos 212. 3.21. Cos 212. Considering cos 212, we do not see 212 on our diagram. So what can we do? Remember, trigonometry, as we also consider the reduction formula, that part of reduction. Where do we have 212? Let's try to reduce it and see if it's going to have an angle which is 32 or any other angle inside of the triangle. Remember, angles in a triangle, they add up to 180. So if we add these two from 180 degrees, we're going to obtain 52, or simply 90 minus 32. That's 58. Supposed to be 58, not 52, but 58, guys. 90 minus 30, that's 58. All right, so that's 58 degrees. Anyways, so we want to figure out, can we have these acute angles, 32 or 58? From 212, we know that 212 is going to be in the third quadrant before 270. Remember, this is 180, 270, so 212 is somewhere there. This is our 212. So what is the acute angle that is here? It is simply 212, this one, minus 180 of a straight line. 212 minus 180. That is the case, which is going to give us 32. So it means there is 32 degrees here. If we add 180 plus 32, 180 of a straight line plus this 32, it will give us 212. So you can reduce this one. It can be reduced from reduction. It is the same as what? Cos 180 plus 32. Remember, when you're dealing with the reduction, you work around 180 and 360. Those are the angles that you work with. It's either 180 minus this, 180 plus this, 360 minus this. That is the condition. So there is 180 plus 32. Just like what we have, guys, if you are given cos 180 degrees plus theta, how do you simplify cos 180 plus theta? This is theta. This is 180 minus theta. This is 180 degrees plus theta. This is 360 degrees minus theta in the fourth quadrant. So 180 plus theta is in the third quadrant, which is the quadrant for tan. This is for tan. Remember from your cast, guys, your cast concept, this is for tan. Where cos is what? Negative there. cos is negative. So it was supposed to be minus cos theta. That is what we are used to. But we are no longer having theta, guys. What represents theta in our question is what? The angle 32. So if it was going to be minus cos theta, in our case, it is going to be minus cos what? 32 degrees, which is the acute angle. Theta represents the acute angle, and our acute angle is this 32. So that's it, guys. Know your reduction formula. Know your reduction formula as much as you can. So minus cos 32 means minus what? Because we have that cos 32. Cos 32 is what? Cos 32 is k. So it's minus k, just like that. Because we have it. So guys, you see trigonometry. They will be playing around something that you'll be knowing. They want to test you. Do you know your reduction formula? They are playing around reduction formula there. The same part with the other question, 3.22. Same concept on 3.22. Sine minus 322. Once sine carries a negative, what is that you know? Sine minus 328. Once sine carries a negative, this is a negative angle. And for negative angles, we know that will be in the fourth quadrant. That's where we have minus theta. And this is the quadrant for what? For cos, not for sine. So it means it will be minus sine, this one. Minus sine 328. So let's reduce this. 328. Which quadrant are we going to have 328? It is going to be the fourth quadrant. All right. So sorry for that. 328 is going to be in the fourth quadrant, somewhere like this. This is where we've got the angle of 328. So what is the acute angle in that quadrant? The acute angle is always between horizontal and this line. Between horizontal and this line. Horizontal and this line. Horizontal, and that's how you take the acute. Not this one, not this one, not this one here. This one. No, never work there. This one between the horizontal line and this axis. So meaning to say this is the angle that we want, which is our acute angle. How can we find this angle? If we know that the whole of this angle here, the whole of this up to here is 328. What about this one that is remaining? Is simply what? 360 minus 328. 360 minus 328 was going to give us 32. So this is 32 degrees here. In between, if you add these two, 328 plus 32, it was going to give us 360. So the acute angle is what? 32. Remember, in the fourth quadrant, in terms of theta, where theta is the acute angle, how do you write it? So that is how you're going to write it. So it was going to be minus sine what? To get the same 328 that we see here. We are supposed to get the same number, 328, but reduced in terms of this. So it will be 360 minus theta, where theta is the acute angle in that quadrant. What is our acute angle there? That's 32. Just like that. So this is sine, just like we are given sine 360 degrees minus theta. How are you going to simplify this? Sine 360 degrees minus what? Minus theta. In the fourth quadrant, it's not for sine, it's for cos. It's the quadrant for cos. Their sine will be negative, so it will be minus sine theta. But as we are not having theta, no, there's no theta here. There is an angle for that theta. So it is going to be what? This minus, take note, it's already there. The one that we removed here, it's already there. So do not confuse this minus and the minus that we are going to have on reducing our sine. The sine of this will be minus sine theta. So it will be minus sine. What is our theta? The acute angle. So it's minus sine 32 degrees. Just like that. So this is what you're going to have. The minus that we already had and the minus for the reduction that happened. Minus, minus, that will be what? Positive. So it's now sine 32 degrees. Guys, you see the reduction. It will be hide. They will be trying by all means to hide that. If you understand that reduction, in an easier way, please use that. They will be trying to hide it. So now you can substitute now, because the 32 is something that we have here on our triangle. According to our triangle, remember sine from our circle to our opposite over hypotenuse. That is our opposite here according to our 32 degrees here. This is our opposite, and this is our hypotenuse. So it is going to be equal to what? Opposite, the square root of 1 minus k squared over what? The hypotenuse. What is the hypotenuse? It is 1. Dividing by 1 does not affect anything, so it will remain as it is. 1 minus k squared under the square root, just like that. So this is sine whatever that you're given there in terms of what? In terms of k. So you see, guys, revisions are very, very necessary. You need revisions before exams. Before exam, you need revisions. All right, so let's quickly work out this so that you can finish. You're almost there. 3.3, prove that this whole part is equal to cos theta, the square root of, so we are given the square root of 1 plus cos 90 plus theta, right, times the sine of 180 degrees minus theta, like this. So the whole of this part, it is supposed to be equal to the cosine of theta. All right, so this is easy, guys. Taking the left-hand side, just gonna work with the left-hand side, which is the complicated side, right, which is our complicated side, as it is 1 plus cos 90 plus theta times the sine of 180 degrees minus theta. So if we are to take our left-hand side, we can see that we have this one, cos 90 plus theta, all right? This is from our core function, all right? Remember your identities, ratios, core function, where cos 90 plus theta is equivalent to what? To cos, all right? Remember, cos changes to a sign, so it will be negative. All right, let me write them here, guys. Cos 90 plus theta. It's in the second quadrant where cos is negative. So it will be minus sine theta, this one. It will be minus sine theta. When it is sine 90 degrees plus theta, because in the second quadrant, sine is positive. So cos will be positive. So it will be written as cos theta. All right. So that's it, guys. In this case, ours, it's 90 plus theta under a cos. So it is going to be negative sine. So that's 1 plus, we change this cos. So it gave us what? Minus sine theta. Okay. Sine 180 minus theta, from our reduction, we saw that, guys, this is found in the second quadrant. This is theta. This is 180 degrees minus theta in the second quadrant, second quad from our cast. This is the quadrant for what? For sine. Sine is positive here. So this one is going to give us positive sine. That's times sine theta. It will just be positive, this one. All right. So that's it. This is where we are with the simplification. We can see that there is a negative here. Yes, it's a product, but as we are multiplying, plus and minus, that's a minus. So multiplying sine and sine was going to give us sine squared theta, sine times sine. All right, what can we do, guys? Our answer is cos theta. How can we end up with a cos where there is only sine like this? How can we end up with a cos? Remember from your Pythagorean identities, the cos squared of theta plus the sine squared of theta is equal to what? It is equal to 1. So what made us to have 1 minus sine squared, 1 minus sine squared? It was simply making cos squared the subject. So cos squared theta, if we make it the subject, it means we're going to take this to the other side. So it's going to be 1 minus sine squared theta. That is what it means. So where you see this 1 minus sine squared theta, guys, whenever you see this, it can be replaced with what? Cos squared in place of it. And this is our situation. And that's our situation in this case, where we have the 1 minus sine squared theta. So what is its equivalent in terms of what? In terms of a cos. It is cos squared. So that's the square root of cos squared theta, guys. We know that a squared and a squared is just like the square root of x squared is what? It's x. A square and a square root neutralizes. So the square root of cos squared is what? It's cos theta. So this is cos theta. And that is exactly what we have here on the right-hand side. So we have proven this, guys. This is exactly what we have on the right-hand side. So do revise as many questions as you can. Try to figure out how questions can be given. Try to attempt in as much as you can. So that is it, guys, for this one. And a complicated one on question 3.4. This was a little bit complicated for 6 marks, but not that complicated because these are just angles to be reused. All right, so let's see. We are given 3.4. I'm just gonna start by reducing whatever that need to be reduced. All right, sine minus 60. What can we do? Remember, I talked about this, guys, in all right, let me do this way. And I have a lot of things. Remember, if you're talking about positive angles, this is theta. 180 minus theta, 180 plus theta. This is 360 degrees minus theta, which is opposed with negative angles. This will be minus theta for negative angles. All right. Talking about this one, it will be theta minus 180, theta minus 180 degrees. These are called negative angles. These ones. They move in the other way, which is the clockwise direction, the one that we are used to. So when you are referring to sine minus theta, it's the negative there, which lies in the fourth quadrant. For cos, remember your cast concept. This is for cos. It's a quadrant for cos. So if it is a quadrant for cos, definitely sine there will be negative. So this is just like minus sine, right? Minus sine 60 degrees times cos 180. No matter that you are dealing with these ratios, guys, when you're dealing with angles which are direct at these points, 0 degrees, 90 degrees, 180 degrees, 270 degrees, 360 degrees. These ones, know them by head. Well, just use your calculator. These are just like special concept of applying our to say, okay, sine is 0, it's 0. But cos is 0, it's 1. So this one, just use your calculator, guys. All right. So cos 90, that's negative 1. All right. If you do not know this, guys, that's negative 1, or just use your calculator there. All right. Minus tan squared 135. This is tan squared 135. We just need to try to reduce first. Let's reduce the tan 135. We talked about this previously. 135 is going to be in the second quadrant. So from 180, this will be 45 degrees. This is 35. So that if you add, it will be 180. So it is simply like we have got tan of 180 like this. It's simply like we have got tan 180 degrees minus 45 degrees to get 135. So it's in the second quadrant, and this is the quadrant for sine. So their tan, it's a negative. So it's negative tan 45 degrees. So this one, it's negative tan 45 degrees. Take note. Negative tan what? 45 degrees. From our reduction, we can reduce this one. So that's a negative, but with a what? A square. Take note, there's a square there. So this one was going to be reduced to negative tan 45 degrees. But you can also square this, okay? times sine 270. I was talking about this 090, whatever these angles. Use your calculator when you see them. Do not even worry there. All right. Sine 270 is what? -1. Whether you use your calculator or use your head, no one is going to know that you have used your calculator there. All right. So this is it. All these calculations, just write them somewhere. They are supposed to be shown. It's part of your working. Show them somewhere in your answer book. You're showing that. Okay. Then we move on to this minus tan 300. Again, we can reduce this one. 300 is in the third quadrant. Remember, 300 somewhere there. So this is like this, 300 up to here. 300 degrees. The whole of this angle is 300 degrees. So 360 minus 300 will give us what? 60 degrees. This is the acute angle that we have in that quadrant. So remember, so this was going to be like tan. It was going to be like this, tan 360 minus 60 minus 60. So that we get what? 300. 360 minus 60 is what? Is 300. But remember the quadrant that we are in, fourth quadrant, it's for cos. This is the quadrant for cos. Where tan is what? Where tan is a negative. This is the quadrant for cos. So tan is negative there. So it's going to be like this, minus tan 60 degrees. This is the quadrant for cos. So definitely tan there is going to be what? It's going to be negative. Okay? Remember, that's a product. You're going to multiply to cos 210. 210 is in the third, this one like this. This is where we have got 210. So definitely 210 from 180, it was going to give us 30 degrees. We subtract from 180, it was going to give us 30 degrees. So the angle in between here, in between, the acute angle in between this point will be what? 30 degrees. So for you to get 210 degrees, you're going to add 180 plus 30. That is the condition. How can we get that one? That is how you ask yourself. So it is cos what? 180 plus 30. If you add these two, you're going to get what? 210. So our acute angle being 30, and this quadrant is for tan, as you can see. This is for, sorry, in this quadrant, yes, for tan, 180 plus what? 180 plus theta is for tan, as for a positive angle. So as we are working with the cos, it means cos will be what? Negative. So it's negative cos of the acute angle. You take the acute angle always. So these are the calculations that you're supposed to just show aside and simplify into this manner. Reduced, whatever that can be reduced. So this is where we are. So some of the angles, as you say, we did not manage to simplify them because they say do not use a calculator. But I was talking about important angles that can be used, like 180, 270, those ones. The rest, they fall under special angles. The rest, they fall under special angles. So it's either you're going to try to simplify first, then you apply your special angles, all right? Try to simplify this negative concept. As you can see here, it's a product. So that's, okay, that's an equal. The negative was going to be positive. So this will be just sine 60 degrees, all right? These two, you multiply, all right? If you move on to this part, it's going to be this part on its own. So, but take note there, how it's going to be like, it's going to be what? Negative, this negative times this negative, so it will be positive. Remember, when a negative is being squared, it's going to be positive. So it will be positive, this one. So it's going to be positive tan squared 45, or just tan 45 squared, all right? Negative, yeah, all right? Yes, one thing up to the end. Remember, guys, it's a product. So you take this one as one item up to the end like this, as one, this one as one. So what does it mean? It means there's negative times negative, which is positive. Positive times negative, which is what? which was gonna be negative at the end. Okay. Which was gonna be negative at the end. So it was gonna be like this, negative. All right, that's negative tan 60 times cos 30. All right. This is where we are. This is where we are. And we have to be careful with our simplifications, guys. We have to be extra careful with our simplifications. I want to figure out the cos minus 30. Where did we take it here? Then this minus tan 60 was from this one. Okay, 300 is in this quadrant, so it's going to be negative, negative. So now we have got a negative there. This is under, this is minus. All right, all right, all right, all right, all right. Let's see. Guys, there's supposed to be something here, here, here. I want to figure out, just sorry for that. I'm gonna figure out here. All right, here it's negative, which is fine. Then the tan 300 said it's gonna be negative, this one. So it's gonna be negative tan 6, which is okay. All right, then, all right, take note, there we have got a product of these two. Okay, so we are going to have like a negative tan on its own, then the cos on its own. So this one is negative, guys. All right, this one is just negative. This one, it's just going to be negative. All right, so let's see. Let's put our values here, sine 60. Let us apply our special angles, our sine 60. Remember, from our special angles, we're going to have something like this. That's 60, 30 here. And this will be 1, 2, square root of 3. All right, so having the sine of 60, all right, the sine of 60 here. Remember, sine opposite over hypotenuse according to our sine, this one. This is opposite, this is hypotenuse, so it's square root of 3 over 2. So it's going to be square root of 3 over 2. Then at tan 45, this one is going to be taken from this triangle. We've got 45, which is your special angles, guys. Go through your special angles. Remember, it's 45, 45, 1, 1, square root of 2. So tan 45 from our tan, that's to our opposite over adjacent. Opposite over adjacent, that's 1 over 1. So that is what? 1. So this one was going to be plus 1 squared minus tan, the tan of 60. All right. So if we are to consider, we have got the tan of 60 here. All right. The tan of 60. From this part, it was going to be what? The tan of 60. Tan, remember, opposite over adjacent. So that is opposite over adjacent. So it's the square root of 3. Opposite over adjacent. So that's the square root of 3. Opposite over adjacent, that's the square root of 3 times the cos 30. Cos 30, according to our diagram here, this is where we have got 30. So cos from cos up adjacent over hypotenuse. So according to 30 degrees, this is our adjacent, this is hypotenuse, so it's square root of 3 over 2. So that was going to be square root of 3 over 2 there. We're going to have the square root of 3 over a 2 like this. All right, so that is it from our simplification. We just have to be, just try to work out the values that you're given. So is this going to give us like minus half? All right, so you can also try to work out from your calculators and see if you simplify minus tan 300 multiplied to cos 210. Multiplied to cos 210. Just to confirm, it is going to give us -3/2. So that is it. So anyways, let us try to simplify here. This is square root of 3/2 plus, so this one was going to be 1. All right, then we've got negative. Remember, this is just a product, guys. Our sides, we can multiply square root of 3 times the square root of 3, which is going to give us 3. So that's -3/2. All right, so we're going to have -3/2 like that. Okay, so this is -half at the end. So it was going to be -half if we simplify the square root of 3/2. 1 minus 3/2, that's a -half. Since the denominators are the same, we can simply combine the numerators, which is square root of 3 minus 1 over what? Over 2, since we've got the same denominators in that case. So that is how questions can be like. All right, so let's go through our questions. If there is anything that you notice not familiar to your simplifications, let us know, guys. Let's communicate so that we can work out as many revisions as we can. But that is how our questions can be like. Let's try to revise as much as we can.